Hey team, I'm back. This is lecture 13 or video 13 or something like that. And it is, roughly speaking, a review of some things you probably learned in high school. I know, isn't that nice? Um, More specifically, this is your lecture on measures of central tendency and variability. These are going to become really important concepts to us. And while you've probably learned about measures of central tendency before, you might not have learned about measures of variability. So, we are going to do some examples. You'll see on my screen, I've been playing around. Don't worry about what's up there. Calm yourselves. We're going to use a few examples to learn this material, and we're going to start by giving this, by creating a new vector. I'm going to use a vector called x. So I'm going to say x gets, and now I'm going to use a function that you will not need to know, but that you should copy dutifully into your console, because we're going to use this example. I'm going to say x gets round r norm, and then I'm going to give it three values: 1,000, 10, 10. So just FYI, again, these are not things you're necessarily going to need to know. I'm using this to create the example rather than to teach you these functions. But R norm creates a random normal vector. So what it does is make a normal distribution with 1,000 observations. It will have a mean of 10. That means the top of the curve will be centered at 10. And also a standard deviation. We're going to learn more about what that means in a second, of 10. And then I'm going to round it to the nearest whole number so that it looks like that. Okay, so now you can see in the environment pane that x is a numeric vector from 1 to 1,000, etc. And it has a pretty wide spread. You can see the first few values are 7, 21, 26, etc. on my screen. Note that because this is a random generator, your specific values will be different. The shape of your curve will be similar. The results will be similar, but they won't be exactly the same, because our norm, that means a random normal. And so your computer is going to choose a different random selection than mine. Don't freak out. Okay, so now we have x. I'd like to start by taking the mean of x. The mean is the numerical average. It's also the second number that I gave to the R norm function. So if that function has done its job, the mean of x should be roughly 10. So let's find out. Recall that when you use mean, it's a function that goes mean. And first you say what you want it to take the mean of, in this case x. And then you're always going to say NA dot RM equals true. Remember to do true in big letters. Yes, a mean of 10.111. That's super close. Yay. So what is the mean? Take a second to remind yourself. The mean is just the average. So we add up all the numbers and we divide by the number of observations. So in this case, we could do something like sum of x is 10,111. And we're going to go sum of x over the number of observations, which is 1,000. Yep, there it is. So it's the it's the sum of all of the values divided by the number of values. You take the average every day in your head. Don't worry about it. Second is the median. Now, in a normal distribution, the median is going to be roughly the same as the mean. It is the value that divides your distribution, or divides your vector in half, so that 50% of observations are above and 50% of observations are below the median. Again, you don't actually have to know how to calculate because R is going to do it for you. This is the joy of R. I don't ever want to see anybody taking a numerical average by hand because that's a wonderful way to introduce error. So let's do median x, comma, na.rm equals true. 10. That's really good. That's all I have to say about that. A funny thing about R is that because it was created primarily for people who use mostly numerical data as opposed to categorical data or character data, it doesn't have a native mode function. So remember from high school that mode is the most common value in the data set. Now, again, I have rounded I've rounded the distribution here such that all of the values are whole numbers. So if I were to say head says, show me the first 6 values. So head of X, yep, those are all whole numbers. So the mode in a normal distribution should be the same as the median and the mean. But because there's not a native function, the easiest way to look at the mode is to do the following. You're going to say head. So this is a bunch of nested things. So head, parenthesis, sort, parenthesis, table X. Outside of table X, but inside of sort, you're going to go comma, decreasing equals true. So before I hit return and return the value, which should be 10, I want to note, I want to describe what I've done. So start from the inside. The inside function here, the inside-most function is table X. Now, you've seen table before. It says, how many times does each unique value appear? That's what it does. And when we sort something, we can sort it either, it sorts from default. The default behavior is to sort from least to most. But what we want is to see the most common values. So we're going to sort that table. Decreasing equals true means start at the top. And then I don't want to see all the possible values. I just want to see the first few because what I'm looking for is the most common one. So we're going to just say, we're going to wrap all of that in head to say, only give me the first 6 or so. All right, here we go. There we go. I am pleased to announce that the most common value is indeed 10. 10 shows up 49 times, 11 shows up 46 times, etc. Now, were we to just say something like, show me the beginning of table X, we would see the values in order. And it would look something like that, and it wouldn't be very informative. It would tell you that the most extreme values are the smallest values. Starting at negative 25 shows up once, negative 20 shows up once, etc. That's not super useful to us. So we really want to sort the table. Remember, we're sorting the table by the number of times the thing appears and looking at the beginning of that. In any case, this is not something you're going to need to know how to do. We will have other ways of finding the maximum number of values when we absolutely need them, but mostly we're going to be using mean and median instead of using mode. And that's primarily because we'll be quantifying stuff. Okay, that's the end of central tendency, mean, median, mode. Make sure that you know how to write those functions. So mean of whatever you're taking the mean of, comma, na.rm equals true. That's up here in what, 1, 2, 3, 4, 5, 6, the 6th line down from the top of my console screen. Median operates exactly the same way. In this case, we're taking the median of X, but you can also take the mean or the median of a, of a column in a data set. And remember, to do that, you are going to give it the data set name. Sorry, let me do this in the correct order for you guys. I think this is very confusing. I'm looking in a mirror. In any case, you're going to give it the data set name, $, the variable name. So you can take the mean and median of a variable. And in fact, that's going to be an important thing to do. So good to know that you can do that. On to variability. Now, this is something that you may not have done in high school, that may be much less intuitive than either mean or median, but nevertheless becomes a really important idea in our work. And that's because when we talk about margins of error or confidence intervals, those are to a first approximation kind of the same thing, it's going to really matter whether our data are distributed in a really tight curve or in a much broader curve. I know you can't see my hands that well. So, and the measures of variability are what tell us how spread out are the values in my variable or in my vector. So we're going to use the same, we're going to use the exact same variable, x, or vector, whatever you want to call it. And we're going to first take the variance. Now, variance is not, in my mind, a super useful thing. It's sort of important to statistical calculations, but we won't use it that much. The function looks exactly like the functions for median and mean. That is, we take var x, comma, na.rm equals true. And it's 105.4882. Why is it so big? It is so big because the variance is a squared measure. This is an artifact of the time when, oh, you woke up. Hi. Henry, do you want to come say hi to my class? Look. Here's Henry. He woke up from his nap. Hi, everybody. I'm going to finish making the video, okay? Do you want to wave? No? Okay. Wait for me for 2 more minutes. Okay? I'll see you in a second. Oh, hello. I'm back. Apparently my work time is over. Okay. So the variance is the distance from the mean for every observation, all of that added together and squared. So for each observation, you find out how far is it from the mean, and then you square that number. And to get the variance, you take the average of those squared numbers. Yeah, squared distances don't make that much sense. What makes more sense... Where's Dada? Dad is at the store, and he'll be back in just a minute. Can you give me 2 minutes? Thank you. Go read a book. So that's fun. So variance is not that useful to you. It is, again, the distance from each observation to the mean. You record all those distances, then you add them up. Sorry, you take all those distances, you square them, you add the squares, and you take the average. It tells you something about how spread out the distribution is, but the more useful thing is the standard deviation. The standard deviation can be interpreted, oh my God, so many mammals. You're hearing dogs, you're hearing my husband coming home. The standard deviation is, roughly speaking, though not mathematically exactly speaking, the average distance to the mean. So if your average observation is further from the mean, then your Henry is jumping up and down, then your standard deviation is going to be bigger and your distribution is going to be broader. So let's take the standard deviation of x. Goes like that, na.rm equals true. 10.27, that's really good because it's close to, as you recall, the standard deviation we gave to the R norm function way back at the beginning of this lecture. So what I want you to do, in addition to knowing how to use these functions, mean, median, variance, var, and yes, Daddy almost finished the toilet. You're learning so much about my home life. Good Lord. Okay. I also want you to learn that the standard deviation can be thought about as something akin to the average distance to the mean. Yeah? Okay. Next video should be a little more chill. Anyway, I'll see you in video 14. Bye.